Facing upside down, so we know the value for a has to be negative as indicated here in the function. They're giving us some hints, and they're asking us to find those missing values for b and c in the equation. So the first thing I always suggest in any question is use what's given to you and start making sense of what you see. So on this graph, it's telling you one of the points is 5, 0. So I'm going to go on a hunch, and I'm going to indicate that this point here is the point 5, 0. Further, they're telling you that the x-coordinate of the maximum point is 3, which basically they're giving you the vertex. So we know the vertex includes the axis of symmetry for where x is 3, and we need to find obviously the y if we're interested, not that they ask us to. But this is a huge hint, because at this point I know that this diagram is getting split in half at x is 3, which means that this point here is the point 3, 0 along the x-axis, with a 4, 0 right here. If that's the case, then given that this is symmetrical, I have a bounce of 2 units between the 5 and the 3, and if I do this again on this side, I know that this point here is 2, 0 and this point here is 1, 0. With that information, and again this is also another jump of 2 units, with this information I can go ahead and I can create 2 binomial terms. Notice that these are going to use the opposite sign of whatever the value for x is, as indicated here. They're both positive, so here they'll both be negative. Now initially I'm going to get x squared minus 6x plus 5 initially. Because this parabola faces upside down, I'm going to multiply the entire trinomial by -1. That's going to give me negative x squared plus 6x minus 5. So now I've solved for b. I know that b is equal to 6, and I know that the y-intercept c is equal to -5, or at least c is equal to -5 of the intercept. So this coordinate point here would be the point 0, -5. So if they ever ask you this in a different phrasing, where instead of just answering the intercept, you're actually answering what is the y-intercept, remember, a y-intercept is actually a coordinate pair, so this is what would be your answer. In this example, no, because they're just asking for the value of c. Second part of the question, they're asking you for the domain where x is equal to between 0 and 6. So what I'm going to do is, I've already put this in y equals, so I put in the actual equation I just computed here. And now I'm going to go to second graph, and you can see that here are the values from x is 0 to x is 6. The range, if you notice, y has a maximum value of 4 and a minimum value of -5 given this restriction. So in this question you want to answer this with -5 less than or equal to y, where y is still less than or equal to 4. If you wanted to take this a step further, just for the sake of practice, since we know that our axis of symmetry is 3, and you were to plug in 3, you can actually use your calculator for this, or you can just look right here. You see where it says 3, 4 or 3, 4 for the y? That's one way you can tell that that's the vertex. Now if you needed to do this manually, you can also plug this into the equation, which is kind of superfluous given that calculator is already doing it for you. How would you do that? Plug it in. -3 squared plus 6 times 3 minus 5 will yield you 4.